Okay. Anka, will you give the start when we can start?
It's on.
It's on?
Yeah, it's on.
Okay, so welcome to everyone. This is the dual plenary session on the grid security of the 5th AIEE Energy Symposium. That's the Italian Association for Energy Economics, and I welcome all the participants, including or starting with the distinguished guests that are part of the panel for the discussion today: Salvatore Pinto, Matteo Codazzi, and Massimo Derchi. I decided to use the friendly formula. There is no need to introduce Salvatore Pinto. There is no need to introduce Matteo Codazzi. There is no need to introduce Matteo Derchi, because they are well-known protagonists of our grid system. So I will take 2 minutes and then leave immediately the floor to the first speaker to make some provocative questions. The grid security, we know, has been addressed as a technical issue in the past, avoiding brownouts, avoiding blackouts. The Energy Authority, ever since 20 years ago, has designed incentives to reduce the number of minutes of interruption on the grid in order to provide quality. Of course, frequency control has always been very important, because you know that a lot of new technological apparatus of our industrial system 4.0 has the need of a very tight control of frequency, and Italy has been doing an excellent job on this result, I would say, on this aim. But then I have the following provocative questions for the year 2050. We are going to the decarbonization target for the year 2050. The intermediate target is 55% of renewable energy by the year 2030. These are the new targets of the European Union. So Europe, Biden or not Biden, Trump or not for Trump, now Biden, is going again, I think, that's my personal view, alone in the world. We don't know exactly what China will do, what India will do, what America will do. These are, in Russia, these are the 4/5 of emitters of CO2 emissions in the world. Europe is only 10-12% at the maximum. So we are going alone on our direction, possibly setting the path for the world. This is the technological challenge. But of course, we will be 1/10 of the world anyway, in terms of results of our efforts. So what are the issues for you, grid managers and grid protagonists? This is a very simple question in order to achieve those results and be credible and have resilience of our systems. This is the only provocative questions I put to you. I leave you free for your presentation, and according to the order, I will propose Pinto, Codazzi, Derchi, waiting for Valtorta to be part of the panel. So I'll gladly give the floor to Salvatore Pinto. Please, the floor is yours.
Thank you, Carlo, for your introduction. Thank you for the invitation. It's a very good introduction. I have no slide, but I would to give you an overview about the technology, about the issue and the opportunity that we have today. We started in your presentation saying that Europe is only 10% of the general emission, CO2 emission, but I think that is an opportunity. Why is an opportunity? Because apart that the climate change is the major issue. Today we are in the COVID issue, but the climate change will be the major issue that we have in the next 10 years. Then Europe in the past lost all opportunity in the new emerging technology. Do you remember microelectronic? Do you remember internet application, connection? We lost everything. That was a premium for United States. Now is a premium for China. Do you remember also the last mistake that we make in Europe, in Italy, mainly than the other country, that we have invested a lot of incentive, but we have not building any industry in the renewable, because the major part of the money was for China, not for Europe. Now where we are? Now we are in the situation that Europe have a great opportunity to jump in the new technology. It's true that we have only 10% of emission, but first of all, we are the major story in the civilization in the world. We are the leader in some things. And I think that this is an opportunity to be the leader also in the climate change. For sure, I want to repeat some things that I said in my speech in Berlin, that I was invited to speak about IPCI, one of the major projects that Europe launched for the battery systems, storage systems. Why I'm speaking about the storage systems? I think that the storage systems is the pivotal technology for the energy transition. Because without storage, we'll have a huge problem. We have a huge problem from the automotive, because obvious that more electrical car we have in the street, more stress we have for the grid. That we need also new technology for that. But automotive represent an important steps for the reducing the emissions. That is important. That new technology means that we need to develop a new storage systems at low cost, without any environmental issue. And for Europe, that is an opportunity, not to follow Chinese. For sure, lithium technology is for the automotive is the only one, because we need the high density energy. That is also true for the mobiles application or whatever. But don't forget that lithium is already in the hand of China and the major part in South America. Then we have the risk that we pass from the oil geopolitical issue to the lithium geopolitical issue. That means that Europe needs to develop their own technology. I think that if I look at the last 10 years, we have a very impressive research in the, for example, flow battery. There is a lot of patents that were already developed. And I think that will be a revolution. There is not one only technology. There is not a killer application, but there is a different technology that will go hand to hand with the others. I want to speak about stationary storage systems. That is the new frontier. For sure, we need the totally green chemistry for this kind of battery at a low cost. We need to consider the total cost of ownership, not only what is the cost for kilowatt hours, but how many cycles this battery have, what is the duration of the battery, what is the cost of ownership of this battery. In the actual technology in the storage systems, we have lithium, we have cobalt. That means that we have some issue for to recycle this battery. For sure, we have the second life for this battery, whatever. But the issue to manage this kind of storage systems remain. Then the stationary battery is an important step also for the grid, because we need some storage systems that have some particular characteristics. Apart of that, will be a possibility to enter in very short times in the grid. We need these systems, large systems, to give the possibility also for the automotive to have a backup in this kind of storage before the grid. That means also for this kind of technology is an important possibility to go. But for Europe, it's very important that this new technology will be based in raw material that is everywhere, is easy to found. And I know that there is some technology that will enter in the market quickly. I think that will be, we are not so far from this kind of result. Depend how much money will be invested. And Europe now, I said before that are investing 1 billion, creating in Europe with the IPCI, not only systems that to found the company, but is a matrix organization of competence that where a lot of European companies are working together to develop these new storage systems that will be hand-to-hand with the lithium, that in any case will have a new technology also in this kind of storage systems, because also in the lithium ion lithium battery there is a new technology that are arriving, more efficiency, more density, whatever. That I think that we are really, I'm quite optimistic about this kind of revolution. I'm so optimistic also because this kind of revolution will be followed also with the digitalization. Digitalization, storage, renewable will get together. Why they go together? You can imagine when we have in the future, obviously not tomorrow, but a lot of storage system everywhere. More or less, you can imagine the same revolution that the smartphone was for the telecommunication. We have small, medium, and large storage systems for different uses. The large systems will be important for to manage the frequencies, to balance frequencies, voltage. But if you can imagine that we have a battery everywhere with artificial intelligence software, but also blockchain, you can imagine that will be a new utility model, because you can store energy from renewable or which kind of energy. Automotive will be part of this kind of systems, because they represent also storage systems in the market. But for the consumers, that means that they will exchange totally the energy end-to-end directly. Obvious that our market is under regulation, is strongly regulated, but the technology is going, is advancing very well in very short times. That there is a need also for the politician, for the regulation, for the authority to understand that the speed of the market needs more advanced attention for that. Another issue that I want to touch is, you know that starting from the 2020 project, when we had the target to have only 30% of renewable volumes now in the market, then we have every time, starting from Juncker, we said not 30%, but 40%. That was also all nation prepared a plan for renewable that we say we are ready to have more than 40, 60%. Now we are speaking about 55 for the 2030, but remain an issue, a big issue. Permitting remain an issue, is an issue in Italy, but an issue also in Europe, not only in Italy. Because at the end, everybody is saying we have a very ambitious project. For sure, it's a more political issue. In the reality, I say that there is two transitions. One is a transition that the people tell, another is the reality. In the reality, we are very far from this objective. Again, storage will be important also for that, because if you are not a so large renewable systems, you need more storage. at least to have more possibility to use the renewable permission that we have already in the market. For storage, and for this reason, I repeat, storage is a pivotal technology. At the grid, the security of the grid is obvious, strongly linked with that, because there is, in any case, a huge investment in renewable, and renewable create a lot of stress to the grid. The investment and also the automotive that will become more electrical is another huge stress. For some country, there is another kind of stress. For example, Italy. Italy is a long geography. That means that you need a network of connection. Maybe you have more production in the south, and you need more energy in the north. Gas, in any case, remain important, because it will be one of the source of energy that give a possibility to accomplish the result that we want to have in the energy transition. That is my introduction. Thank you for the attention. I'm ready to.
Thank you, Salvatore, and I welcome also Valtorta, who joined us while we were starting this conversation. I launch another provocation for the future panelists, Matteo Codazzi, but also Derek and Valtorta. You have spoken, Pinto, about a lot about lithium batteries and this new technology. However, on the road of Damascus, I must admit, on the road of Damascus, I went, back and forth several times. One was the battery lithium, but now there is hydrogen. So there is apparently a new wave of research and interest in using hydrogen, which could have some alternative or, not complementarity, but a substitution concept in the view that you have presented. So while I give with pleasure the speech to the director of CESI, the CEO of our, star in the research in our field, Matteo Codazzi, I will prepare you to think also of what will happen to hydrogen as an alternative to batteries in this new scenario. Matteo, the floor is yours.
Thank you, Carlo. It's a pleasure to be here with you and an honor to be invited. So just thank you for the magnificent introduction to CESI, Carlo. So just a few words, that we are really a powerhouse in the global engineering, testing, and power system consulting across the world, with many locations globally, as you can see from this chart. And even after the acquisition of our now subsidiary Kima Labs, we're providing, testing services related to the innovation in the energy sector all across the globe. In addition to that, we are advisor to many regulators and governments and utilities, of course, and energy investors. And we provide advice with anything related to the innovation, the energy transition challenge. So I think Professor Berlino has already, mentioned this important news that the European Commission is now finally targeting zero emission European economy by 2050. And most recently, and most importantly, the EU has revised upwards its target on decarbonization, aiming to cut 55% of greenhouse gas emissions by 2030. So I think it's a very important step forward in creating the key pillars of the clean energy for all Europeans policy. All right, an important point that we need to mention when we talk about European Union is that currently European Union is a heavy reliance on foreign energy imports. More than half of the energy consumed is imported, with a cost of approximately 350 billion euros per year. And in terms of energy, European Union is the largest net energy importer in the G20. Almost the total oil products are imported, almost 95%. And most importantly, 83% of natural gas is also imported, with an increasing trend in the last years. And moreover, several European Union countries depend on Russia for natural gas import, implying a huge problem in terms of energy security, of course, because of the lack of diversification. And from 2008, Russia has become the main supplier and the main primary energy commodities to Europe, basically. So there is a huge problem of energy security in terms of supply for Europe going forward. And that's why moving to a decarbonized economy would not only allow an improvement, of course, in greenhouse emissions and in the environment, but would also represent for the European Union a huge step ahead in terms of improving its security, our security of supply. This is particularly evident, I would say, in the power sector. Power sector, as we all know, is a forerunner in the evolution to a carbon-free power generation. The recently issued 10-year network development plan formulated by ANSOE clearly highlights how fast renewable generation is expected to grow in Europe in the next 2 decades, entailing a dramatic cut in CO2 emissions. That plan foresees a renewable energy penetration of approximately 62-64% in 2030 in comparison to the current 35%, and then CO2 emission cuts by 2030 of 57-58%, a measure that a parameter, an indicator that is now just 35%. So a huge improvement and I would say, very brave targets looking forward. However, as also Salvatore and Carlo have already mentioned, there are a few issues with managing a power system when you have a high degree of renewables into that system. We all know that renewables are inherently volatile. And if not properly managed, they could also have an impact on the energy security in terms of curtailments or other sorts of problems. Now, a power system with a large share of renewables will produce, in particular, higher frequency deviations due to the lower level of inertia in the grid system. In fact, as we all know, the conventional power plants, such as turbo gas, coal, combined cycle gas turbine plants, have a high level of inertia thanks to their rotating generators. When the zero inertia renewable power plants come into the grid and substitute those generators, any change of the supply-demand balance will cause higher frequency deviations in the system with the related problems in the security of supply and potential disruption. We recently witnessed in Europe some problems in terms of network operations due to the high penetration of renewables. In June, I just want to mention a couple of them. In June 2019, there was an error forecast in renewable production in Germany with a 6,500 megawatt deficit, which led to significantly frequency deviation, the risk of power failure for the entire Europe. And also in August 2019 in UK, lightning caused the loss of small distributed generation to power stations, but the high frequency with a loss of power of 1,800 megawatt, but the high frequency deviations caused the disconnection of approximately 1 million customers. So this is a real problem that we need to face. And of course, there are many technical solutions that are undergoing that are definitely the real solution to allow high penetration of renewables. So if we want to enable the renewable generation, we must be sure that the power system, the power grid is improved and is enhanced in order to be able to easily manage and accommodate the high share of renewables that is coming. And in particular, there are three areas in which I would three main issues in which I would focus a little bit today. One is the need for internet connections, connecting renewable generation with demand. Second is storage infrastructure to enhance the flexibility in the system. And last but not least, the use of green hydrogen to enable an effective cross-sector coupling. Well, the first solution, interconnections, basically regards the possibility of using interconnections to match any overproduction or any underproduction of renewable and be able to move the excess or deficit of energy from one country, from one region to the other, basically. ENTSO-E foresees the implementation of 130 gigawatt of cross-border capacity in Europe, with increasing investments over the year. One example also is Germany, which will connect through 3 HVDC corridors. There's with larger shared generation and basically in the north of the country, in the North Sea, with production areas in the south center. And this is a key pillar of the German Energiewende. Second, another innovation that will have a crucial role in the energy transition will be the use of a storage system to increase the flexibility of the electric system. I think Salvatore has already very well mentioned this. I don't want to spend, therefore, too much time on these, but, you know, just to pinpoint a few issues. One is, and as you can see in the chart on the left, the graph on the left, shows a 2030 simulation that we have run, which underlines basically the necessity of storage for renewable energy. Otherwise, up to 50 to 20 gigawatt of renewable energy would be likely curtailed in a typical day at European level. This is based on a simulation that we've done of the whole interconnected European market and the whole interconnected power system of Europe. However, you know, we are all placing our best bets on, you know, the improvement and the further improvement of storage and batteries, et cetera, et cetera. But we all know that, you know, that we still need a further improvement of such technologies. And, you know, there are many promising technologies, as Salvatore has already very well mentioned. There is nevertheless an important fact that we need to keep in mind, even if we are all faithful in improvement of the technology for batteries. We must also keep in mind the potential problems related to the scarcity and concentration in few countries of lithium and cobalt reserves. And, you know, we might, you know, in the future, risk of having some, security of supplies issues, not with energy, but with those scarce resources, basically. So that is why when we talk about storage, we believe as Chesi that, you know, the best thing would be to a proper differentiation among various differentiation strategies, not, you know, putting all the bets in a single technology, but have a sort of a portfolio of different, you know, technologies for storage, and particularly not only for batteries, but also diffusion of other technologies, not only for producing batteries, but also thinking about reusing, recycling batteries, and also using second life batteries. That, you know, is an important area to address the risk of scarce supply of critical materials. In reference to storage, a specific focus is needed for electric vehicles. Indeed, the mobility sector presents a relevant share of greenhouse gas emissions, we all know. The benefits of using the electric vehicle is strictly dependent on the energy mix of each country, and Italy, I would say, is certainly a favorable situation, which is, I would say, comparable to the European Union average, meaning that basically we produce energy. Our portfolio of energy mix is very much comprised of renewable, less polluting, less polluting sources in comparison to other countries that are mainly and heavily edged towards, for instance, carbon and coal. Italy, if we look at, of course, there is also an improvement in terms of emission. If we look at typical electric vehicle in comparison to a typical diesel engine based internal combustion engine vehicle in terms of emissions, we have computed that advantage from ranging from 67% to 55%, depending on, you know, whether you take into consideration the full, you know, chain of producing electric vehicles. But anyhow, there is, you know, all in all, however you look at it, there is a clear advantage in terms of emissions for an electric vehicle. Moreover, the battery characteristics that are board of those cars could be optimally coupled with the needs of electric network, enabling, aggregated electric vehicles batteries to provide ancillary service, frequency regulation, et cetera, to the power markets. And that could be habilitate a new market and a new and innovative market and new innovative business models also to foster the growth not only of the electric vehicles but also of of renewables themselves. In Italy, for instance, there's a possibility is already permitted by the so-called UVEM pilot project by Terna, which allows the aggregation of production and consumption units to provide grid services. And furthermore, as you all know, the Italian Energy Authority has implemented further measures that are, kind of suggested to favor or intended to favor the electric vehicle participation in providing ancillary service to the grid. The electric mobility could also boost the recovery of the economy with positive impacts on GDP. And I think this is an important issue as well, even because, everybody is now looking at how to sustain the economy after the pandemic. I just want to mention a couple of data. The implementation investments for the public charging infrastructure could bring a total 2 billion euros in aggregate up to 2030, and I'm just referring to Italy. And that would drive an estimate saving of 1.1 billion euros of energy raw materials imports, basically per year, per each million of electric vehicles. So there is a huge payback in those kind of investments. And also, there are many other investments that would be needed in order to foster the distribution network in particular. We know that some experts estimate the GDP economic multiplier, those kind of investments, as much to 2 or 3 times the investment spent. And a recent McKinsey study has suggested that in the case of energy infrastructure, such economic multiplier of investments might further increase to even 5 times. Now, finally, getting to hydrogen. Another element of innovation, of course, regards the possibility to decarbonize other sectors through green hydrogen in particular, which is, as you all know, the hydrogen produced through electrolysis using renewable energy. Indeed, we need to take into consideration that some sectors in particular are hard to decarbonize, even in a situation where we have a lot of renewables, hard to decarbonize through electrification due to the fact that their processes are quite difficult and being converted to sort of a different process system. And that is why we believe that in particular hydrogen has bright future in terms of helping those sectors recarbonizing in an efficient way and in a way that is efficient and does make sense in terms of costs and returns on investment. In particular, if we look at the refining, iron and steel industry that, as we all know, are very energy heavy and hydrogen heavy even today users. Let me just take one step back, and you can see that in the chart that is shown on the right hand side of the slide. This is a scenario of the national power plan, national plan for the power system.
Excuse me, time, please.
Yeah, I'm concluding. This is basically the last slide. In 2030, we do expect there are going to be a lot of problems with overgeneration of renewables. So hydrogen, actually, the green hydrogen permits to use this excess of renewable energy that otherwise will be curtailed to use in order to produce green hydrogen, as we all know, is based on using water and electricity through electrolyzers. I think we all know that there still needed a lot of investment to further improve the technology and the performance of electrolyzers, but we believe there is a huge potential there, because if we look at the potential economies of scale and improvement in performance of that technology, we see in 5 to 10 years future a huge potential to further decarbonize once again in a very with no subsidies way, basically in a very IRR focused to further decarbonize the sector. So to conclude, I think a decarbonized European Union economy allows security of supply and independence Of course, the renewables introduction and boost does help the economic recovery, and I think this is a very important point to keep in mind. Of course, all these objectives may be achieved through additional power transmission infrastructures, additional resources for system flexibility, and also hydrogen, as I was saying, and electric vehicles might play a significant part. Huge investments are needed, so we are looking at, you know, a regulatory and legislative framework to be put in place, and, you know, the huge and massive scale of the European Union and other governments, you know, packages to further boost the economy after the pandemic. Thanks a lot.
Thank you very much, Matteo. Very challenging and interesting presentation so far. I add another provocation. The geopolitical issue. Both Pinto and you have addressed the idea of energy security in the concept of becoming less dependent, essentially, on the oil producing countries. But now the oil producing countries are producing ammonia. They are part of the green worldwide. So, you know, there is a new geopolitical view of embarking them into this new world rather than keeping them aside. With this, you know, provocation, which may or may not be received by Massimo Derchi, I leave him the floor, and after him, Valtorta. Please, Massimo.
Thank you very much. Let me share my slides. Here we are.
Yes, please confine yourself, you know, in the 10-15 minutes as usual, so we can have some time for the final discussion and final second round for all of you.
With pleasure. So thank you very much for having invited me. I have two issues that I'd like to discuss you today. The first is why gas will remain of essence throughout 2050. And secondly, why the gas infrastructure is key for the energy security. Let's start with the first one, why gas? The last European Commission impact assessment on Europe's climate ambitions shows clearly that if 2050 targets are to be met, green gases have to contribute for about 300 million tons of equivalent oil, which means about 50% of the final energy demand in Europe. In the first phase, natural gas will replace coal, but the end picture will see a combination of different green gases, and which means hydrogen, biomethane, natural gas with carbon capture and storage, as a whole. Hydrogen will be a key component of this mix, and if we consider hydrogen, adding up hydrogen itself with e-gas, which means gas is produced from hydrogen, those two will cover about 50% of this gas energy mix in Europe. Why is it so? Well, the answer is very easy. Because the levelized cost of green hydrogen is going to fall sharply, which is driven by two big cost reduction. One is the cost reduction of renewable energy, and secondly, the cost reduction of electrolyzers. If you look at this graph, you may notice two things. The first is how the green hydrogen, which is produced in South Italy, which is the bold green line, will become competitive with gray hydrogen by 2030. And if you consider the green hydrogen produced in North Africa, which is the green line, blue-green line in the bottom, that occurs even earlier. And the second thing which is worth noticing is how fast things are moving. If you see the dotted line and the green line, this represents the difference in forecast is just 1 year. So in just 1 year, there is a difference in 15% in the forecast of the cost of electrolyzers, simply because there is a growing demand for them, and that is actually slashing prices. So we think that at the global level, 25 gigawatt of electrolyzer capacity will be enough to get hydrogen production cost around to $2 per kilo, which is actually the tipping point before 2030 that will make green hydrogen competitive with for a number of applications, and in particular with applications that already use green hydrogen or other hard-to-abate sectors, as we're going to see. Where all this hydrogen is expected to flow into. This is a Bloomberg forecast, which basically assume that by 2050, about 40% of the hydrogen will be used for transportation, which basically means heavy trucks and trains. There will be another 30% roughly for power production, and about 20% will go for industry, refineries, chemical plants, steel, etc. But if this is the picture, if hydrogen is such a key component of energy mix by 2050, what is the role of the gas infrastructure? Well, the first step is to understand how critical it is, the gas infrastructure. And there are three elements that make the gas infrastructure critical. The first, and was mentioned by Matteo Codazzi earlier on, is storage, seasonality and storage. In the left side of the slide, you see how variable is the gas consumption in Italy throughout the year, and in comparison, how stable it is the power consumption. How can we cope with such a seasonality? Simply because we have storage. If you just focus on Italy, we have a yearly consumption between 70 and 75 billion cubic meters per year, and we can store underground 17 billion cubic meters, which means more than 20%, about 25% of the yearly volume can be stored underground. It can be stored for months. We basically store it in summer, and we extract it in winter when it is needed, and that helps us to cover up to 40% of the daily demand in winter, which is a huge number. And the last important factor of gas storage, it's cost. Storing gas is very cheap. The cost is in the range of €5 per megawatt hour. And you can compare it with every other cost, batteries included, which is typically well beyond €100 per megawatt hour. So you have a huge reservoir for no matter how long at a very small cost. There is a second reason why infrastructure is critical, which is basically its flexibility. Our infrastructure today carries natural gas only, but it can be readapted easily to convey a variety of gases, which will include natural gas, biomethane, and hydrogen. Hydrogen, which may be green hydrogen, blue hydrogen. So it's there are several ways to do that. In a first stage, you can do it by blending hydrogen into natural gas, but at a later stage, you can even think about separating the network in two and having part of a network running natural gas and or biomethane, and the second part running hydrogen. But there is a third reason why the gas infrastructure is so crucial, and that is its cost. This is again a forecast by Bloomberg, which compare the cost of delivering large volume of gas to Germany in different way. And as you can see, the importing hydrogen from North Africa through Italy via pipeline is by far the cheapest way, even cheaper than the production of green hydrogen via offshore parks in northern Germany. Together with other TSO, and so the transmission system operator, we have made a study last year to understand how the hydrogen network, European hydrogen network, may look like in 2050. And you can see that it's easy to conceive a network which will be run throughout all European countries, and that network will be mostly around 70% made of repurposed natural gas pipelines. and only 25% is composed of new lines. So the levelized cost of transport for such a network will remain extremely low. We're talking of something in the range of 0.1, 0.2 euro per kilo every 1,000 kilometers, which is, as we have seen, the most effective way of transporting over a long distance hydrogen. This network will emerge progressively throughout 2030 and throughout 2040. We estimate that by 2030 there will be something in range, something around 7,000 kilometers, up to 23,000 kilometers by 2050. And we may have, as Italy, we may have a key role, because we have a gas infrastructure which spans from Sicily up to northern Italy and then across the Pianura Padana and northern Italy. So that infrastructure is an infrastructure that will be progressively become redundant in the next decades and can be easily adapted to convey hydrogen in part, and the remaining part of the network to convey methane or biomethane. Last slide, and I will conclude to say what at SNAM we are already doing on hydrogen. There are a lot of activities going on in order to assess or prepare for the readiness to hydrogen of our infrastructure. If we focus on the pipelines, all new pipelines which will be built by SNAM are now based on materials which are hydrogen ready. We have prepared in the past months a set of specification for all piping components, and so we are able now to build pipelines will be inherently ready to convey hydrogen. But we are also studying and assessing the compatibility of existing network, and we estimate that about 70% of our pipelines are made of material of steel, which is compatible with hydrogen. We're doing studies on storage. We have a 2 years deep study, including testing and analysis for our existing reservoir, together with Politecnico di Torino. We have already assessed that we can inject 2% of hydrogen without any issue on our network of storage. And we will proceed with test and analysis throughout 2021 in order to assess the maximum percentage of hydrogen up to 100%. We're working on compression stations. We're working on some studies on final user boilers. And we're also doing all that in cooperation with larger TSO in Europe. We have created under our impulse a group called H2GAR, Hydrogen Gas Asset Readiness, which include the 6 largest TSO. And the aim of this is to exchange information, exchange studies, exchange the work that is being done, so that we can collectively accelerate as much as possible the transport of hydrogen through our infrastructure. Thank you very much. This was basically what I wanted to tell you, to remind you how important is the gas infrastructure even in 2050.
Thank you very much. So now we leave the floor to Giovanni Valtorta, who represents the demand. We have seen the technological supply of new green, of new items, of new technology, of new research. Now let's see what those who are going to use it as an important part, I think, of our energy system has to say. So I, with pleasure, leave the floor to Giovanni Valtorta immediately.
Thank you, Professor. I hope you see my presentation.
Yes, thank you.
Well, I will provide you an overview about the DSO challenges and the new role of the DSO in the energy transition. Well, Distribuzione is the Italian branch of the Enel Infrastructure and Network Global Business Line, which is present in 8 countries all over the world. And these figures you can see makes Distribuzione, one of the largest distribution system operator in the world. Well, up to now, Distribuzione connects almost 30 gigawatt of renewables, 17 gigawatt in the medium voltage and 7 gigawatt of the low voltage, which is 90% of the Italian photovoltaic capacity, almost 50% of the Italian wind capacity. And this is impressive, taking care that the peak power demand of the whole Italian system and the corresponding flow in the distribution network. So the distribution system is going quickly to become a distributed generator with 2000 high medium voltage points connected to the transmission system. In addition to that, the European Commission launched the Clean Energy for European package with Horizon 2030, and Italy, as a consequence, developed its PNIEC, the Integrated National Plan for Climate and Energy, which is based on energy security, so the resiliency of the system, in our case, the development of the energy internal market, with an active role of the consumers, which are enabled by the open meter. The decarbonization, we will expect 40 gigawatt of renewables, among more than 30 gigawatt connected to the distribution system, and is expected also a reduction of the an improvement of the efficiency, with a reduction of 43% of the primary energy. Also the research and innovation are foreseen. All these targets will have a huge impact on the management of the Italian electrical infrastructure. So the traditional model with a passive distribution method is quickly going to change with the huge increase of distributed generation. Will require not a distribution network operator, but a distribution system operator, which is a catalyzer and able to integrate all the new energy actors: transmission system operator, renewable storage system, active demand, vehicle to grid, aggregators, industries, and will be able to facilitate their relationships. Also, we have new market scenarios driven by the electric mobility and the electric demand increase. So we expect from 4 to 6 million of electric vehicles connected and circulating in Italy in 2030. And the connection of and the management of these charging infrastructures will be a challenge for the distribution system operator, but also the vehicle to grid will provide a huge distributed storage system. We developed the second generation of digital meters in 2017, which is characterized by an open protocol, providing meter information for the home automation systems, and also the availability of load curves for all the customers. And this can support the dynamic prices market models, and will enable also new added value services provided by all the customers and prosumers, which will be part of the new energy market. The distribution system will be characterized by advanced monitoring and self-healing capabilities, and the real-time data exchange with the transmission system operator and the distributed resources. The network development and the operational planning will take advantage from the renewable connected in order to make use of their flexibility in operating the system. So new services will be provided by distributed energy resources, and this will maximize the hosting capacity of the network. So for this reason, our regulator has launched at the end of 2019 the new regulation, the dispatching activities, and two roles are foreseen for the distribution system operator. It has to be a neutral facilitator to enable the flexibility services provided by resources connected to its network for the transmission system operator ancillary service market, but also the distribution system operator will be a buyer of services in order to operate its network with new facilities in order to, as I said, to maximize the hosting capacity and ensuring as well the quality and security of supply. So for this reason, the Distribuzione is preparing a project focused on this second role of the distribution system operator as requested by the regulator. Another important issue is the implementation of the System Operation Guideline Network Code, which foresee an information exchange between distribution system operator and transmission system operator. The Distribuzione has developed a double-layer architecture in order to collect information by the distributed energy resources and transfer in real time to the transmission system operator, allowing the observability of the distributed resources and improve the security of the whole power system. Well, the performance of the distribution system operator is usually measured by the SAIDI, so the duration of the long interruption for the low voltage customer. The Distribuzione has been able to reduce 70% this indicator from 2000 up to now, reducing as well the operating expenses by means of projects like the smart meter, the first generation of smart meters, the network automation and workforce management, and so on. But now the climate change require new challenges about the resilience of the system. You can see here a picture of the Uppsala Glacier in Argentina, taken 85 later. So the first one is at the beginning of the last century. A big glacier now has been replaced by a big lake. Coming to Italy, we can see on the left the Marmolada glacier has been reduced a lot in 4 years and is expected to disappear at the end of 2030. And on the right, you can see the extreme weather events that are related to the climate, to the global warming, that can be not only heat waves, but also snowstorms, water bombs and windstorms in uncommon places. So here you can see how many events we had in Italy, excluding snowstorms from 2010. All the country has been covered by some damages. and the impact on the infrastructure foreseen by the European Joint Research Center from today to the end of the century is impressive.
Yes.
Well, the e-distribuzione developed some tools in order to evaluate the risk on its network and to prepare the resiliency improvement plan foreseen by the regulator. We use meteorological data set, models and real events to estimate the probability of the events. Then we evaluate the damage, so the unsupplied customers. And so we evaluated the risk and we are able to make our plans. In this graph, you can see the shape of the unsupplied customer during an extreme weather emergency. The first peak is due to the depends on the event strength and the robustness of the network. Then you have a reduction due to the remote control operation in our network, and then you can reduce the unsupplied customer by means of emergency generators and quick repair, and then you come back to the normal operation. So in order to reduce this kind of impacts, we can make intervention on in the robustness of the network, reducing the event probability by means, for example, introducing overhead cables instead of normal buried conductors, or improving the meshing of the and the telecontrol of our substation in order to reduce the impact. Another important tool we are developing is an automatic management of the extreme events, because we are thinking about using the same tools developed for the planning of the resilience improvement in a deterministic way. So if we have a good weather forecast, we are able to estimate the impact of the events, and so we are able to optimize the resources to be allocated to resupply our customer as soon as possible. So we use the same tools in a deterministic way. So this will be very interesting in the improve the reaction of the distribution system to extreme weather events. So summarizing the last slide, the secondary substation will be an Internet of Things hub with sensors, allowing system and equipment monitoring, and will be connected through fiber optic connection system, allowing advanced automation. Distribution system will integrate electric vehicle charging infrastructure. We can be a huge distributed storage system. Prosumers will be active participants of the electricity market. Renewables will participate actively to the distribution system operator. And the second generation of electronic meter will enable new added services for the system for electricity market, and the distribution network will be an open resilient platform for enabling all these services, hopefully for a smarter world. Thank you for
Thank you, Giovanni. Thank you, Dr. Valtorta, Engineer Valtorta. I think we are at the end of the session, and I immediately asked all the participants if they want to ask questions to the distinguished panelists. I think this panel has been very interesting, not because we were here, you know, to make fishing for compliments, but I think that we have addressed, you have addressed, sorry, not me, you have addressed the most important issues for the future of the energy transition in terms of batteries, grid management, hydrogen storage, hydrogen development, development of the distribution grid, as Giovanni Valtorta lately has said for Enel. So very important issues for our conference, and I really congratulate to all of you for the quality of your presentations. I'll ask the assistance of the AIEE Secretariat, that is Anka, if there is anybody who wants to intervene, perhaps, and ask questions through the question and answer. I don't see any open question in this moment. If not, I would ask any one of you three.
We are sorry, we have to close the session. It's over.
It's over time. Okay, so nobody wants to get a 1 minute reply. I think no controversial issues. So there's not any one of you four, Pinto, Codazzi, Valtorta, or Darky, who wants to reply to the others. I think you are in a stream of agreement, but I don't want to force you to, you know, to be considered, you know, in a team of agreement. But if you are, okay, no controversy. So really, thank you again to Salvatore Pinto, to Matteo Cotazzi, to Massimo Derchi, to Giovanni Valtorta for this very, very interesting session on behalf of AIEE, the Italian Association for Energy Economics. Thank you so much.
Thank you very much.
Thank you.
Thank you.
Thank you very much.
Bye.
Thank
Thank
you.
Bye.
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 Thank you to everyone.
Happy festivities.
Oh, excuse me.